button to subscribe my channel and also click the bell icon to get notifications of all my latest uploads. Thank you.
Hello friends, welcome to my channel. In this video series, I will be discussing Nda-Ii 2 2017 paper. This is set B of Nda-Ii 2 2017 paper. It was held on 10th September 2017. So let us start with question number 1. If A cap and B cap are two unit vectors, then the vector A plus B cross A cross B is parallel to. So let us start with, we have A plus B cross A cross B is equal to A cross B plus B cross A cross B. And we know that for three vectors A cross B cross C is equal to A dot C dot B minus A dot B dot C. So we'll be using this formula here and we'll get A dot B A minus A dot A B plus this is B dot B then A minus B dot A then B. So A dot B, this will be some constant K, unit vector A minus this will be 1, so this is B, this will be A and this will be some constant K vector and then B, or I can write K outside, this will be A minus B minus 1 and A minus B, A minus B. So this gives me K plus 1 multiplied by A minus B, and this matches with option A. So option A is the correct answer. The given vector will be parallel to the vector A minus B. So option A is the correct answer. Option A. Let us see one more. Question number 2. Force vector F is equals to I plus 3j plus 2k acts on a particle to displace it from the point A, that is I plus 2j minus 3k, to the point B 3I minus j plus 5k, then the work done by the force will be. So we know that work done is equals to force multiplied by distance, and distance here is the vector AB. So let us find the vector AB first. Vector AB is equals to x2 minus x1, that is 3 minus 1 I minus 1 minus 2 minus 1 minus 2j plus 5 minus minus this is 3, 5 plus 3k. This gives me 2I minus 3j plus 8k. Work done will be dot product of force vector and this distance vector. Force vector here is I plus 3j plus 2k, so this will give me 1 multiplied by 2 plus 3 multiplied by minus 3 plus 2 multiplied by 8. This gives me 2 minus 9 plus 16, and this is 9 units. This matches with option C. So C is the correct answer. Now question number 3. Question number 3. Is for any vector A cross I square plus A cross j square plus A cross k square is equal to. Here we know that A cross I whole square is equals to z square plus y square, and A cross j square is equals to x square plus z square. A cross k whole square is equals to x square plus y square. Now we need to add all these three. This gives me 2 times x square plus y square plus z square. And this is 2 times mod a whole square. This matches with option B. So option B is the correct answer. Option B is the correct answer. Now let us see question number 4. Question number 4. A man running round a race course notes that the sum of the distances of 2 flag posts from him is always 10 meter and the distance between the flag posts is 8 meter. The area of the path he encloses is. Clearly we can see that this is an ellipse and the 2 flag posts, these are the focuses. This is F1, this is F2. Let us say P is the position of the man. Now it is given that the sum of these two distances PF1 and PF2 is 10 meters. So PF1 plus PF2, this is given by 10. And we also know that the sum of these distances PF1 plus PF2 is 2 times the major axis. So 2A is equals to 10. This gives me A is equals to 5. It is also given that the distance between the flag post is 8 meter. Means this distance is 8 meter and we know that this distance is 2 times C. So 2 times C is given by 8. This gives me C is equals to 4. And for an ellipse we know that A square is equals to B square plus C square. So from this we'll get B square is equals to A square minus C square. A square here is 25 and C square here is 16. So 25 minus 16, this gives me 9 and B is 3. Now the area of the path he encloses is, that area is given by, area is equals to pi AB. That is pi multiplied by 5 multiplied by 3. This gives me 15 pi. And this matches with option B. So option B is the correct answer. Option B is the correct answer. Let us now see question number 5. The distance of the point 1, 3 from the line 2x plus 3y is equal to 6 measured parallel to the line 4x plus y is equal to 4 is. Here we are given a point. This point is 1, 3 and a line. Suppose this line is 2x plus 3y is equal to 6 and one more line is given. This line is 4x plus y is equal to 4 and we need to measure the distance of this point measured parallel to this line from the line 2x plus 3y is equals to 6. So we want this distance PQ. Now from this equation the slope of this line is minus 4, m is equals to minus 4. Since this line is parallel to this line, so slope for this line is also minus 4, m is equal to minus 4. So any line having slope minus 4 and that passes through point 1, 3 will be y minus 3 is equals to, this is minus 4 into x minus 1. This gives me y minus 3 is equals to minus 4x plus 4. Or I can write 4x plus y is equals to 7. Now I want the point of intersection of this line and the given line, and that can be found by solving these two equations. First equation is this one, second is 2x plus 3y is equal to 6. Let us multiply this equation by 2. This gives me 4x plus 6y is equals to 12. And if I subtract these two equations, I will get, this will get cancelled. This is minus 6 plus 1 minus 5y, and on the right hand side this is minus 5. This gives me y is equals to 1. And if I substitute this value of y in equation 1, I will be getting 4x is equals to 6. This gives me x is equals to 3 upon 2. Now I have the point Now the point Q is 3 upon 2 comma 1. Now I need to calculate the distance PQ. Distance PQ is equals to under root of, this is 3 upon 2 minus 1 whole square plus 1 minus 3 whole square. This gives me square root of, this is 1 upon 4 and this will be 2 square, that is 4. This gives me under root of 17 upon 4, or I can say under root 17 upon 2. And this matches with option D. So option D is the correct answer. Let us now see question number 6. If the vectors ai plus j plus k, I plus bj plus k and I plus j plus ck, where ABC is not equal to 1 are coplanar, then the value of 1 upon 1 minus a plus 1 upon 1 minus b plus 1 upon 1 minus c is. Here we are given that these three vectors are coplanar, and we know that the condition for coplanarity is the value of the determinant should be 0. Determinant a 1 1, these are the coefficients of I, j and k. So a 1 1, 1 b 1, 1 b 1, 1 1 c. Value of this determinant should be 0. Now we want the value for 1 upon 1 minus a, 1 upon 1 minus b and 1 upon 1 minus c. So to make it 1 minus a, 1 minus b and 1 minus c, let us do some transformations in this determinant. C2 as C2 minus C1 and C3 as C3 minus C1. Now this determinant will be, column 1 will remain as it is. This is A1 1 for C2. This is C2 minus C1. So 1 minus A, this is B minus 1 and this is 1 minus 1, that is 0. For C3 this will be 1 minus A, 1 minus 1 is 0 and this will be C minus 1. Value of this determinant should be 0. So let us write the value of this determinant. This will be A multiplied by these two, B minus 1, C minus 1. Then minus, this is 1 minus A and this will be C minus 1 minus 0. So C minus 1. Next will be 1 minus A multiplied by minus of B minus 1. So I can write 1 minus B. Value of this should be 0. Now let us divide both sides of the equation by 1 minus a, 1 minus b and 1 minus c. This gives me 1 minus a, 1 minus b and 1 minus c. On the right hand side this will be 0 only. So the first expression will be a upon 1 minus a plus 1 upon 1 minus b, because this 1 minus a and 1 minus a will go, c minus 1 and 1 minus c will go and this will become positive sign. So 1 upon 1 minus b, and here I will be having 1 minus a and 1 minus a will go, 1 upon 1 minus c equal to 0. Now this will be 1 upon 1 minus b plus 1 upon 1 minus c, and this will become minus a upon 1 minus a. Now if I add 1 upon 1 minus a to both sides plus 1 upon 1 minus a, similarly on this side plus 1 upon 1 minus a, this becomes the right hand side of our question, and this will be 1 minus a upon 1 minus a, and this gives me 1. So value for this expression is 1. Let us now see question number 7. The point of intersection of the line joining the points minus 3, 4, minus 8 and 5, minus 6, 4 with xy plane is. Let us solve it. We are given 2 points. Suppose this is minus 3, 4, minus 8 and this is 5, minus 6, 4. So the equation of the line passing through these 2 points will be let us say this equals to lambda. Now any point on this line will be x is equals to 8 lambda minus 3, y is equals to minus 10 lambda plus 4, and z is equals to 12 lambda minus 8. And since this line intersects the xy plane, so z is equals to 0. Let us substitute this equals to 0. This gives me lambda is equals to 8 upon 12 and this is 2 upon 3. So x is equals to 8 into 2 upon 3 minus 3. This is 16 upon 3 minus 3. This gives me 7 upon 3. Similarly, y will be minus 10 into 2 upon 3 plus 4. This will be minus 20 upon 3. So 3 4s are 12 minus 20. This gives me minus 8 upon 3. And z is equals to 0. So the required point is 7 upon 3 minus 8 upon 3 and 0. And this matches with option A. So option A is the correct answer. If the angle between the lines whose direction ratios are 2 minus 1 2 and x 3 5 is pi upon 4, then the smaller value of x is. We know that the angle between the lines whose direction ratios are given is cos theta, that is cos pi by 4, is given by 2x plus 3 multiplied by minus 1 plus 5 multiplied by 2 divided by, this is 2 square plus minus 1 square plus 2 square and square root of x square plus 3 square plus 5 square. This gives me cos pi upon 4 is 1 upon root 2 and this is 2x minus 3 plus 10 upon, this will be 4 plus 1 plus 4, that is 9, and square root of 9 is 3, and this is x square plus 9 plus 25, this gives me 34. So x square plus 34. Let us simplify this further. This will be 2x plus 7 divided by 3 under root of x square plus 34. Now if we square both sides, I will get 1 upon 2 and this will be 4x square plus 14x into 2 plus 49 divided by 9 multiplied by x square plus 34. So if I cross multiply, this gives me 9x square plus 306. This will be 4 2 ja 8x square plus 56x plus 98. This will be x square minus 56x plus 208 is equals to 0. Let us find the value of x from this. Value of x is given by minus b. So 56 plus minus under root of b square. This will give me 3136 minus 4ac, so minus 4 multiplied by 208, this is 832 upon 2a, so upon 2. So this will be 28 plus minus 24. Value of x is, if I take positive sign, this will be 52 and for negative sign this will be 4. So smaller value here is 4 and this matches with option B. So option B is the correct answer. Now let us see question number 9. The position of the point 1, 2 relative to the ellipse 2x square plus 7y square is equal to 20 is. We have to find whether this point lies outside the ellipse, inside the ellipse, on the ellipse and at the focus. So let us substitute the value 1, 2 in this equation. This gives me 2 into 1 square plus 7 into 2 square. That should be 20. So this is 2 plus 28 and this is greater than 20. So the point lies outside the ellipse and this matches with option A. So option A is the correct answer. Let us now see question number 10. The equation of a straight line which cuts off an intercept of 5 units on negative direction of y-axis and makes an angle 120 degree with the positive direction of x-axis is. Let us see. Here we are given that the straight line cuts off an intercept of 5 units on negative direction of y-axis. So let us draw this. This is y-axis and this intercept is minus 5 units. So 0, minus 5. And makes an angle of 120 degree. This angle is given 120 degree. And this is the straight line. Now we want to find the equation of this straight line. For this straight line, the slope is 120 degree. So m is equals to tan 120 degree. And this is minus root 3. So equation of the line having slope minus root 3 passing through the point 0, minus 5 will be y minus y2. So this is y plus 5 is equals to m, that is minus root 3, x minus x1. So x minus x1 is 0. So this is the equation of the line. And this can be written as y plus root 3x plus 5 is equals to 0. And this matches with option A. So option A is the correct answer. Let us see question number 11 now. The equation of the line passing through the point 2, 3 and the point of intersection of the lines 2x minus 3y plus 7 is equal to 0 and 7x plus 4y plus 2 is equal to 0 is. Now we know that the equation of line passing through the intersection of two lines is given by, this is 2x minus 3y plus 7 plus lambda times 7x plus 4y plus 2 is equals to 0. Now since this line passes through the point 2, 3, so let us substitute 2, 3 in this equation. So this is 4 minus 9 plus 7 plus lambda 14 plus 12 plus 2 equals to 0. This is 11 minus 9, so 2 plus lambda times 28. So this gives me lambda is equals to minus 1 upon 14. Let us substitute this value of lambda in first equation. We will get 2x minus 3y plus 7 minus 1 upon 14, 7x plus 4y plus 2 equals to 0. This gives 98 minus 7x minus 4y minus 2 is equals to 0, or 14 minus 7x, this is 7x minus 46y plus 96 is equals to 0. And this matches with option B. So option B is the correct answer. Let us see question number 12 now. The equation of the ellipse whose center is at origin, major axis is along x-axis with eccentricity 3 upon 4 and latest rectum 4 units is. Let us see the solution. We are given eccentricity is 3 upon 4. So E is equals to 3 upon 4. But eccentricity is also equal to C upon A. This gives me C square upon A square is equals to 9 upon 16. Or I can write C square is equals to 9 upon 16 A square. Also we are given that latest rectum is 4 units. This gives me square upon A is equal to 4. This gives me B square is equals to 2A. Also we know that for ellipse A square is equals to B square plus C square, or A square is equals to 2A plus 9 upon 16 A square, or I can write 16A square is equals to 32A plus 9A square, or A square is equals to 32A. This gives me A is equals to 32 upon 7. or b square is equals to 2 into 32 upon 7. This gives me 64 upon 7. Now the equation for ellipse is x square upon a square plus y square upon b square is equals to 1. Let us now put the values of a square and b square in this equation. This gives me x square upon a square. This is 32 square. So 1024. 7 square, 49 will go to the numerator. Y square upon b square. This is y square. B square is 64 upon 7. 64, 7 will go to the numerator. This is equal to 1. And this matches with option B. So option B is the correct answer. I hope you liked it. In next video, I'll be uploading some more questions. So be with me. If you are new to this channel, subscribe it. Thank you.